Hi everyone, I'm Lap-Loi Chung from the National Center for Research on Earthquake Engineering and from the Departments of Civil Engineering, National Taiwan University and National Chung University. This is my name in Chinese, Zhong Li Lai. This is in Korean. Here is the presentation at the forum on improving policies and regulations through lessons learned from the 2017 Pohang earthquake in Seoul, Korea. In this presentation, I would like to share our policy on seismic evaluation and retrofit of school buildings and low-rise buildings in Taiwan. This is the part 1 of the presentation. Existing buildings were designed and constructed according to the codes and guidelines at that time, maybe 20 years ago, 30 years ago, or 40 years ago. And design codes and construction guidelines keep updating. From today's point of view, those existing buildings may be vulnerable. Demolishment and reconstruction is a solution to the problem. However, the number of existing buildings were so large that it is impossible and impractical to demolish and reconstruct all of them. Therefore, seismic evaluation and retrofit is another solution. If a building is found to be insufficient in seismic performance, some retrofit measure can be taken to upgrade the seismic performance of the building to the current standard. This is a picture taken after 1999 Chiche earthquake. A school building was completely collapsed. We were so lucky. The earthquake happened at midnight. No students were there. If the earthquake happened at school hours, the death toll would have been double or triple. Therefore, seismic division was common for school buildings in Taiwan at that time, but not now. Seismic upgrading of school building was a stringent issue at that time, but not now. When facing the problem, we would like to know the volume of the problem. There are more than 26,000 school buildings in elementary and secondary schools from grade 1 to grade 12. In collaboration with the Ministry of Education, we propose strategy for upgrading school buildings. There are several stages here. From comprehensive survey, we know about the total number of school buildings in Taiwan, so that we know about the volume of the problem. Buildings built after 1999 were excluded from this program because we believe that buildings built after 1999, the performance is much better, so that the volume, the total number of school buildings involved in this program is reduced through comprehensive survey. In the second stage, preliminary evaluation, then we have the seismic index, IS, of the school building. And buildings with IS greater than 80, because the performance is okay at this moment, they were excluded from the program. Therefore, the number of school buildings involved in this program is further reduced through preliminary evaluation. The third stage is detailed evaluation. From detailed evaluation, we have the CDR of the building. CDR is capacity to demand ratio. CDR is a building with CDR greater than 1 that means that the seismic performance is okay at this moment, they were excluded from the program. Therefore, the number of school buildings involved in this program is further reduced through detailed evaluation. If the CDR is less than 1, the building will move to the next stage, retrofit design and retrofit construction. In the stages detailed evaluation and retrofit design, peer review is necessary. And in the stage of construction, inspection by professional engineers is necessary. The results from all the stages are submitted to a databank through network, so that we have all the information of all buildings. From comprehensive survey, buildings built before, buildings built after 1999 were excluded. From preliminary evaluation, buildings with IS greater than 80 were excluded. Building detailed evaluation with CDR larger than 1 were also excluded. Therefore, big fishes were screened out through the process. Only the smallest fishes are left, so that we can handle the weakest building first. Therefore, through this screening process, the volume of the problem is reduced stages by stages. Even though the technology of upgrading school building is ready, but it's very difficult to strive for budget. In 2008, we had a great chance. In response to 2008 financial tsunami, the government has allocated 558 billion NT dollar to stimulate economy, in which 18.3, 3 or 4%, 80.3 billion new Taiwan dollar for seismic upgrading of school buildings in elementary and school and secondary school. It is expected that thousands of school buildings went through the process of preliminary evaluation, detailed evaluation, retrofit design, and retrofit construction. 1,500 school buildings were expected to be retrofitted in 4 years. In the years between 2009 and 2012, we have a budget $19.2 billion to have a 6,000 school building preliminary evaluation, 3.8 thousand school building in detailed evaluation, 1.5 thousand for retrofit design and retrofit implementation. With a good beginning, it is half done. Therefore, more budget is followed. In the second stage, from 2013 to 2016, we have budget 6.4 billion NT dollars. In the stage 2017 to 2019, we have budget 9.4 billion Taiwan dollar. And we hope that by the time 2019, all the buildings will completed. All the buildings will be completed. And is retrofit effective? In 2010, we have a verification. In 2010, there's an earthquake called Jiaxian earthquake. And in 2010 is just 1 year after the program is launched. There are 14 buildings in 9 schools. They were damaged, and no retrofit measure has been taken at that time yet. And this is one of the buildings in Yujing Junior High School. And here's the location of the building, and it is about 30 kilometers away from the epicenter here. And this building is seriously damaged. And we believe that if the intensity of the earthquake is a little bit higher, if the intensity of the seismic retrofit effective, in 2010, we faced Jiaxian earthquake. And among buildings without retrofit, 14 buildings in 9 schools were damaged. In 2010, the program has launched just 1 year, so the limited number of school buildings has already been retrofitted. And this is one of the buildings without retrofit. It has been evaluated and was found to be insufficient in seismic performance. It is in the waiting list to be retrofitted, but by that time it has not been retrofitted yet. And this is a school building in Yujing Junior High School, the location here, and it is 30 kilometers away from the epicenter. And this building is seriously damaged. And we believe that if the intensity is a little bit higher, this floor may be collapsed. And this is the space used for the playground for students in bad weather, like raining or thundering. Therefore, if the building collapses, casualty is unavoidable. Next to this building, about 1 kilometer away from the building, and there's another school called Yujing Vocational School. And this is the building, and it has already been retrofitted by reinforced concrete wall, and no damage. Therefore, among the building with retrofit, no damage was observed in 2010 Jiaxian earthquake. In 2016, 7 years after the program was launched, there's a Meilong earthquake in Tainan City. 151 buildings evaluated to be qualified. Only 1 building damaged because the ground shaking intensity is higher than the design one. 58 buildings retrofitted, and this building are high-rise building, high-risk building, and no damage was observed. 85 buildings without retrofit, and this building are of low risk. 18 buildings damaged, but no collapse. And here's an example. In Guilin Junior High School, there are several buildings in this campus. And this is Guanghua building. It has already been evaluated to be not qualified, and it is a low-risk building, and it has not been retrofitted yet. It was damaged, but the damage is not that serious, and the damage state is considered to be moderate. Is moderately damaged. Another 2 buildings. One is Yangming building, the other is Lizhi building. They were evaluated, not qualified, and retrofitted. No damage was observed. There are 3 most common retrofit methods in Taiwan. One is reinforced concrete jacketing. In reinforced concrete jacketing, we make the column, the cross-section of the column, much larger. This is the column with no retrofit. This is the column with retrofit. It can be observed that the cross-section of the column with retrofit is much larger. Another method is adding wind wall to the size of the column along the direction we are going to upgrade. And this is the column with no retrofit. This is the column with retrofit by adding 2 wind walls to the both sides of the column. The third method is adding shear wall. And this is the frame, the span with no retrofit. And this is the frame with retrofit. Originally, this frame is similar to the one next to it. And the window is removed and shear wall is infilled into the beam column frame. The common characteristics of these 3 methods is to make the vertical members stronger and bigger so that the school building can be prevented from being collapsed. This is the first stage comprehensive survey. It was conducted by students of civil engineering. It cost millions of Taiwan dollars. And from comprehensive survey, we know the total number of school buildings in Taiwan, so that we have some idea about the volume of the problem. And also some information were gathered, including name of school buildings, campus map, floor areas of school buildings, and it is important to propose the budget, and number of students in school building, usage of school building. If a school building is not used by students, therefore it will be excluded from this program at this moment. And year bills, if a building built after 1999, it will be excluded from this program. From a comprehensive survey, we know that the total number of school buildings is 26.6 school buildings in Taiwan. And among them, 10,000 school buildings, there's a 37.5% of the total were excluded because they were built after 1999. And we believe that building built after 1999, the performance will be better than the one built before 1999. Therefore, at this moment, buildings built after 1999 were excluded from the program. 16.6 thousand school buildings, there's 62.5% of the total. Move to the next stage, preliminary evaluation. Therefore, from comprehensive survey, the number of school buildings remain in this program was reduced from 26.6 thousand to 16.6 thousand. The second stage is preliminary evaluation. It is conducted by professional engineers according to comprehensive survey. Only buildings built before 1999 is enter into this stage. It takes half a day for a building, and it costs $6,000 for a building. And from preliminary evaluation, we know about the seismic index, IS, of the building. If IS is greater than 80, it is excluded from the program. And the results from preliminary evaluation were submitted through internet to Anchorage, our center. The concept of preliminary evaluation is very simple. It's just a ratio of capacity to demand. To count the capacity of a building, we have to know about the AC. AC is the cross-sectional area of the column in the first floor, and AW. AW is the cross-sectional area of the walls in the direction we are interested. And tau C is the lateral strength per unit cross-sectional area. And tau W is the lateral strength per unit cross-sectional area of walls. Tau C and tau W were prepared by Anchorage, our center. And in order to have the demand, we have to know about AG. AG is the design peak ground acceleration. It can be looked up from the seismic design code. Summation AF is the total floor area above first floor. In this case, is the floor area of the second floor, third floor, and the roof. And W is the structural weight per unit floor area. It is prepared by Anchorage. Therefore, when professional engineers arrive at the school site, they have to measure the cross-sectional area of the column, cross-sectional area of walls, total floor area, and they have to look up from the seismic design codes for the design peak ground acceleration. Okay, from preliminary evaluation, so far 6.6 thousand school buildings were qualified. It counts 24% of the total. And 10,000 school buildings, 37.8% of the total, were not qualified and have to move to the next stage, detailed evaluation. And 10%, 10 school buildings, is very small amount of buildings, are still under processing. Therefore, after preliminary evaluation, the total number of school buildings remain in this program has been decreased from 26.6 thousand to 10,000. The third stage, detailed evaluation, is conducted by professional engineers. According to the result from preliminary evaluation, only buildings with IS less than 80 will enter into this stage. It takes 45 to 60 days for a building, and it costs about, on average, $400,000 a building. And the cost for detailed evaluation is counted by floor area. Therefore, the unit cost is $200 per square meter of floor area. And the result of detailed evaluation is capacity to demand ratio, CDR. If CDR is larger than 1, that means that the seismic performance is okay at this moment. They will be excluded from the program. And peer review is necessary in detailed evaluation. And the results of the detailed evaluation is necessary to be submitted through internet to Anchorage. In detailed evaluation, pushover analysis is conducted. And the result of pushover analysis is in the form of capacity curve or pushover curve. Is the relationship between base shear and roof displacement. And the capacity curve can be transformed into capacity spectrum, which is the relationship between spectral acceleration and spectral density. And the design response spectrum is adjusted so that the two spectra intersect at the performance point, and the performance point is selected according to how much displacement is tolerable. If only small displacement is tolerable, therefore the special displacement will be less. If more displacement is tolerable, the special displacement can be larger. And from the reduced response spectrum, we have AP, and AP is the performance peak ground acceleration, which is the capacity of the structure. And the capacity of the structure is compared with the demand, and the demand is the design peak ground acceleration, so that we have CDR, capacity to demand ratio. So far from detailed evaluation, 1.2 thousand school buildings were qualified. 8.8 thousand school buildings, it counts 33.1% of the total, were not qualified and moved to the next stage, retrofit design. 37 school buildings, about 0.1% of the total, are still under processing. Therefore, after detailed evaluation, the third stage of the program, the total number of the school buildings involved remain in this program has been reduced from 26.6 thousand to 8.8 thousand. Therefore, the volume of the problem has been gradually reduced. And then the fourth stage, retrofit design, is conducted by professional engineers, and the priority according to the capacity and demand ratio from detailed evaluation. That means that the lower the CDR, the higher the probability, the higher the priority to enter into this stage. It takes 45 to 60 days for a building, and it costs on average $300,000 a building. And the cost is counted by floor area. Therefore, the unit cost is about $150 per square meter of floor area. And the result of retrofit design, the professional engineer should provide all the documents for retrofit, including design drawing, and peer review is necessary. And the result from retrofit design have to be submitted through the internet to ENCRI. So far, 199 school buildings were qualified in retrofit design, in the stage retrofit design. Since some of the school buildings were evaluated before the program was launched, therefore in retrofit design, the building will require to perform seismic evaluation again. Therefore, about 200, not that many, school buildings were qualified in the stage retrofit design. 8.5 thousand school buildings were not qualified. It counts 31.8% of the total. They have to move to retrofit implementation. 151 school buildings, not that many school buildings, are still under processing. It costs, on average, $6.3 million a building, and the cost is counted by floor area, and the unit cost is $3.1 thousand per square meter of floor area. In the budget for retrofitting of a school building, at least 70% are used for retrofit of the structure. At most, 30% are used for restoration, including painting or leakage repair. And inspection is necessary. Therefore, retrofit implementation is watched by professional engineers, and the results were submitted through internet to ENCRI. So far, 6.5 thousand school buildings. It counts 24.6% were completed, in which 4.7 thousand school buildings were retrofitted, 1.8 thousand school buildings rebuilt, and 1.9 thousand school buildings, it counts 7.2% of the total, are still under processing. And it is expected that by the time 2019, all the buildings were completed. And peer review. And in detailed evaluation and retrofit design, peer review is necessary. And we believe that detailed evaluation and retrofit design watched by the third party, the quality of the work may be better. And we have a reviewer bank with 40% university professor and 60% professional engineers. And a review committee consists of 3 members, at least 1 university professor, and at least 1 professional engineers, and the third member may be university professor or professional engineer, so that we have the balance between theory and practice. And it costs $6,500 a meeting. And $6,500 cannot be divisible by 3, because in a review meeting, we need a coordinator to collect all the comments and also to draft the review conclusion. Therefore, the coordinator takes more responsibility. He or she was paid $2,500. The other 2 members are paid $2,000 each. $2,000 plus $2,000 plus $2,500, and it makes $6,500. And to sum up our accomplishments so far, 24,500 school buildings, it counts 92% of the total, were done, in which 10,000 school buildings were excluded because they were built after 1999. 6,600 school buildings were qualified by preliminary evaluation with IS greater than 80. 1,200 school buildings were qualified by detailed evaluation with CDR larger than 1. 199 school buildings were qualified by retrofit design with CDR larger than 1. 4,700 school buildings were upgraded by retrofit implementation or retrofit construction. 1,800 school buildings were reconstructed. So far, there are still 2,100 school buildings under processing, in which 10 school buildings in preliminary evaluation, 37 school buildings in the stage of detailed evaluation, 151 school buildings in the stage of retrofit design, and 1.9 school buildings in the stage of retrofit implementation. Thank you. This is the part 1 of the presentation, and the video will be uploaded into this channel, and here's the link to the channel. You are welcome to watch the video. Thank you. Bye-bye.